Interested in here is in talking about, and this is problem number 4. It says, what is the concentration of a solution in parts per million if 0.0584 grams of iron 3 plus is dissolved in 2,362 grams of water? So this involves parts per million, and for parts per million, let me see if I can find a good, yeah. So, I have the water quality statements here, and I'll reference those in just a minute. You can see, I don't know if you can, but the water quality statements have units of milligrams per liter, and they have micrograms per liter, and we'll talk about those in a couple minutes. And I don't know, they have, where is it? Copper and lead. And you can see that copper is in milligrams per liter and lead is in micrograms per liter. So we'll talk about that in just a minute. All right. So back to the homework. So a 1 part per million is 1 times 10 to the minus 6 grams per milliliter. And further, 1 times 10 to the minus 6 grams of solute per milliliter of, typically it's called water, although anytime something is dissolved in water, a better word would be solution. But when the water is 99.99999% pure, they tend, so I see a couple questions there. I'll address them in a couple minutes. Okay, so anyway, it's a solution because something is dissolved in it, but they tend to call it water because it's often drinking water, and we don't want to call our tap water our tap solution. But, and this is based on the fact that 1.00 gram of water equals 1.00 milliliters of water, at least very close to this, which is the density of water, 1.00 gram per milliliter water. Okay. All right, so that's a little bit of background. So what I'm going to do is I'm going to actually calculate my grams per milliliter. And so I have my grams. I have grams of water as well, but because 1 gram of water equals 1 milliliter of water, these two numbers will be exactly the same. So plugging this in, I calculate that it's 0.0584 grams of, in this case, iron 3 plus, divided by, 2,362 grams of water is 2,362 milliliters of water. So the numbers are the same because of the density of water. And I get 0.0584 divided by 2362. 0.000, so let's move into the scientific notation for this one. 2.47 times 10 to the minus 5th. Grams per milliliter of Fe, or grams of Fe3 plus per milliliter of water.
On Blackboard, you have to put in, it won't accept scientific notation, will it?
It will not.
Yeah, you got to put in all those zeros.
Well, I'm not even sure it would take a number this small with zeros, but we're not quite finished yet. So we're going to get a nice number. And so now let me do the next step. So for parts per million, I have this conversion factor that says 1 part per million equals this. So now I have 2.47 times 10 to the minus fifth grams of Fe3 plus per milliliter water. And what's weird about this conversion is I'm going to do the conversion, the whole thing, as, so 1 times 10 to the minus sixth. I'm going to use this equal statement right here, and I'm going to put this entire thing on the bottom. Grams, I'll personalize it to do the Fe3 plus now, per milliliter water. And so you can see my grams, this whole set of units cancels out. And up top, I just put my 1 part per million Fe3 plus. And so I will be left with units of parts per million Fe3 plus. And my units cancel. My whole set of units cancels. And my answer for this one, once I multiply it out, is 2.47 exponent 5 minus divided by 1 times 10, which is exponent 6 minus, and I get 24.7 as my number, and my units are going to be parts per million Fe3 plus. So we do get a nice number out of this, even though it's a tiny concentration, and that tiny concentration unit is called parts per million. Now, and that's all we have to do for the homework. Let me tie it into real life, and this is because, you may encounter not parts per million, but some of the units we saw here. So if I were to go back to my, well, I'll tell you what. I'm going to save the relationship to the water quality data for another time, just because we're focusing on the homework here. But if you want to understand more about your water quality data, I'll do it after we finish all the actual homework today, so we can focus on what's going to be graded. But anyway, there is a relationship, but it's not on the exam, so we'll save it.